Determine the points on the curve y is equal to x cubed minus 4x minus 5, where the gradient is equal to 8. Before we do this, let's just have a look at what we're actually doing here. So, using GeoGebra, I have drawn this curve, and I've drawn the tangent at any particular point. So, here I have the curve, x cubed minus 4x minus 5, and if I move the slider slightly, I have a point P here where I've drawn the tangent, and GeoGebra is working out to be the gradient. Okay, if you can't quite see it, the gradient's up here at 10.52, and we know as we move the across the curve, the gradient changes. You know, here it is positive, here it's 0, and then it's negative, 0 again, and then positive. So we want to know where the gradient is 8, and looking at this curve, we can actually see that there is one point, and the coordinates of P at that point are minus 2, minus 5, and there is another point over here where P is 2, minus 5 at this particular point here. We also have a gradient of 8. So when we do the algebra to solve this problem, we know there are going to be two answers for the value on the curve. So, writing down the curve, y is equal to x cubed minus 4x minus 5. The first step is to find the gradient function. So we're going to differentiate this curve. So dy by dx will be 3x squared, ax to the n, dy by dx is anx to the n minus 1. So differentiating this, we bring the 3 down in front and reduce the power by 1. So that will become 3x squared. When we differentiate minus 4x, it's minus 4x to the 1, so we bring the 1 down, so we get 4x to the 0. But x to the 0 is 1, so we just get minus 4. And when we differentiate a constant term, like minus 5, we actually get 0, but we won't write that in. We want to know where this is actually equal to 8, so we're going to take this and put it equal to 8. So we've got 3x squared minus 4 is equal to 8. 3x is equal to 8. 3x squared is equal to 12. Dividing through by 3, we've got that x squared is 4, and therefore x is plus or minus 2. This is looking quite good because it's looking like what we did in GeoGebra. So we've got 2 points, which is what we wanted. When x is equal to minus 2, what we need to do is substitute back into y. So get the y is equal to minus 2 cubed minus 4 times minus 2 minus 5. Minus 2 cubed is minus 8. Minus 4 times minus 2 is plus 8. Take away 5. So that's quite easy. Minus 8 plus 8 is 0, minus 5. And the other point is when x is equal to 2, then we're going to put y is equal to 2 cubed minus 4 times 2 minus 5. 2 cubed is 8, minus 4 times 2 is going to be minus 8, minus 5, so it's going to be good again. 8 minus 8 is 0, minus 5. So we've got 2 points, one at minus 2, minus 5, and the other at 2, minus 5. So we just go back, quickly look at our GeoGebra again. There's the one at 2, minus 5. Okay, a gradient of 8, and if we move it back over this way, we get the second point at minus 2, minus 5.